Okay, so to talk about converting between polar and rectangular coordinates, we're going to kind of mesh the two together. We're going to compare, well, this point, if it is x, y, then really what we're looking at is technically we can form a right triangle. Okay, the horizontal distance right here is our x coordinate. The vertical distance is our y coordinate. But if we also talk about this point in the polar system, that point is r theta. So r is the length of that segment right there from the pole to the point, and theta is our angle that is formed with the polar axis. So we're kind of meshing these two coordinate systems together and saying, okay, here's this point. If I plot it in the xy system, if I plug it in the r theta system, what are the similarities? How can I convert between the two? So we've created a right triangle. Anytime you have a right triangle, you can, of course, apply the Pythagorean theorem. So x and y are your legs. So x squared plus y squared is equal to the hypotenuse squared. Hypotenuse is obviously r in this case. Now, we still obviously have our trig relationships because it's a right triangle. So if we set up the sine ratio, the sine of our angle is the opposite. The opposite is y over the hypotenuse, which is r. Again, that goes right along with our unit circle because it was based on the same principles that you could build a right triangle. Your vertical component is the opposite, so it is sine. Cosine of theta is equal to x over r, the adjacent over the hypotenuse. Tangent of theta is equal to the y over the x. Okay, so again, it's falling right in line with everything that we've done with the unit circle, with vectors, and now we're doing it with the polar system. Now, we want to be able to use these relationships so that if we have the x value or if we have the y value, we can find the r, so that's the Pythagorean theorem. If we have x and y, we can easily find r. We can easily find theta over here with our tangent expression. What if we have r and theta? We want to find x and y. Well, we need to isolate our sine and cosine. We need to isolate those for y and x. So we need to move that r to the other side by multiplying. So if we rearrange these things, we end up with these three expressions. Y is equal to r sine of theta. X is equal to r cosine of theta. So again, if we know r and theta, we just plug them into those two expressions and we can get x and y. So very similar to our vectors when we were finding the x component and the y component. We plugged in the magnitude times the sine, times the cosine of the angle, the magnitude times the sine of the angle. We got the x component and the y component. If we needed to find the angle, we use the inverse tangent. And I just put the x squared plus y squared equals r squared down there again. Okay, so these are the important formulas that we are going to use to convert from polar to rectangular, rectangular to polar. Now, which do you think is easier to do? Go from x and y to r and theta, or from r and theta to x and y? Okay. Well, let's just do something, find out. You got that written down? Okay. It's really easiest to go from polar to rectangular because we just have to plug it into r cosine theta, r sine theta. There's a little bit more work involved when you go from polar or from rectangular to polar. And you'll see what I mean when we get to those examples. So let's convert the polar point 3, 5 pi over 6 to x and y coordinates. So here's our r, here's our theta. Let's just give ourselves a little bit of a visual before we convert. So this point 3, 5 pi over 6, 5 pi over 6 is in the second quadrant, closer to the x-axis. So our point somewhere over there. Let's make sure our x and y agrees with that. So x is equal to our radius times the cosine of our angle. Y is equal to our radius times the sine of our angle. So the cosine of 5 pi over 6, let's use the unit circle. It's negative square root 3 over 2. So if we kind of just arrange this the way that we should show it mathematically, we've got negative 3 square root of 3 over 2. The sine of 5 pi over 6 is 1/2. So 3 times 1/2 is 3 halves. So that's our point. Negative 3 square root of 3 over 2, 3 halves. So we've got a negative x, we've got a positive y. That aligns with being in the second quadrant. Obviously, the square root value there doesn't do us a whole lot of good when we're trying to compare where it's at. So if you want to get the decimal approximation. Now, you can, of course, check this in your calculator. You can type it in, 3 cosine 5 pi over 6, and compare it to that, compare it to that decimal value, okay, and make sure that they are the same, and they are. And 3 sine of 5 pi over 6. But I do expect that when it is a point on the unit circle, that you will use the exact values. Okay, I do not want decimal values when that is an angle from the unit circle. Now, the next example, 2, negative 200, 200 is not an angle on our unit circle. So this one is okay for us to have decimal coordinates. But I still do want us to think through this for a second. Where this would be, negative 200, let's see here, that would be in the second quadrant as well. It'll be somewhere about right here. Okay, so we're looking for the same result. X equals r times the cosine of the angle, that is degrees. Y equals r times the sine of the angle. We have to rely on our calculator. We have to make sure it's in degree mode because we just did radians, but our angle here is degrees. So 2 cosine negative 200, 2 sine negative 200, negative x, positive y. Let's round to 3 digits after the decimal. Negative 1.879, 0.684. Okay, so the only time decimal coordinates are allowed is when it's not on the unit circle. All right, 2 more here. Square root of 3 pi over 3. X equals the radius times the cosine of the angle. Y equals the radius times the sine of the angle. So the cosine of pi over 3 is 1/2. So that's equal to the square root of 3 over 2. The sine of pi over 3 is equal to the square root of 3 over 2. The square root of 3 times the square root of 3 is the square root of 9, which is 3. So that is 3/2. So we have the square root of 3 over 2 and just 3 over 2. And our angle is in the first quadrant, so positive x, positive y. That agrees. All right, one more with degrees, and we'll be done for a minute. X is equal to the radius times the cosine of the angle. Y is equal to the radius times the sine of the angle. The cosine of 180 is -1. The sine of 180 is 0. So this is the point -2, 0. Think about it for a second. 180 is the negative x-axis. So if you go out to a radius of 2, there you are. That's the point -2, 0 in the rectangular system.